Hi, so this problem is based off of 5.57 from the Eulaby book. And so this one is asking to apply nodal analysis in the phasor domain to determine Ix of t. So we're actually not going to do the full part of this, so just do it in the phasor domain. And so you're going to get a node voltage equation. And on this, want you to put the node voltage equation for V1 in this form, where it's A plus BJ over 10 V1 plus C V2 over 10 plus D over 10. And then for the node voltage equation at V2, want that form to be, let's do A2 A2 V1 over 10 plus B2 plus C2J V2 over 10 plus D2 over 10 equals to 0. So put them in these forms, and then for the exam, I would ask you something like add A plus B plus C plus D to give me an answer to be able to do a check on the quiz. So to be able to solve this, things that I'm focusing on is that you're able to convert from time domain into the frequency domain. So that's going to be both the phasor forms for the signals, and then also being able to convert the elements themselves into that. So we're actually, let me change this problem slightly and actually make this an inductor. So we're changing this to an inductor just to get practice in I'm going to do 1 micro Henry instead. So just to get practice in converting and then writing the node voltage equations correctly. So with this, the conversions, you're going to have that this one translates into 21 E J 0 degrees, and again the 0 degrees goes to a 1, so this is just going to be 21, and with that same thing this is going to be 10.5. And then the elements, so this element is going to be a minus J over 1 micro, which is minus 10 to the 6, and the frequency here is 10 to the 5th. So 1 or minus J over omega times C, and omega is that 10 to the 5th. And for this one, you're going to do, so this is minus J over omega C, and this one is J omega L. And in this case, the omega is 10 to the 5th, and the L is 10 to the minus 6th. So that gives a value of a minus 10J for the capacitor, and then 10 to the 5th times minus 10 to the 6th is a minus 0.1, so 0.1 J, and that's a plus. So, let me draw this. So then writing the node voltage equations, I am going to label this one a V1, and this one is V2. So I would give you these as the labels just to write them into the correct form. So with this then, I need to write the currents in each of these branches. So in this one, it's going to be V1 minus 21 over 5. And in this branch, it's going to be V1 over a minus 10j. And in this branch, it's going to be V2 over 0.1j. And this one is going to be V2 minus a minus 10.5 over 5. And so at V1, V1 minus 21 over 5 goes out of that node, V1 over minus 10j, and then a V2 over 0.1j, or sorry, I forgot to write this middle one. And this one is V1 minus V2 over 5. Sorry, so this one is V1 minus V2 over 5. And that is the 3 currents that are going out of node V1. So on node V2, you have the V1 minus V2 over 5 going into the node, and then going out is the V2 over 0.1j, and then the V2 plus 10.5 over 5. So this is going in V1 minus V2 over 5, and that's equal to V2 over 0.1j, and then V2 plus 10.5 over 5. So I'm going to rewrite this. This should be, actually we want this one, V2 over 0.5. So we're going to just change this slightly as far as part of the question. So 0.5 we'll do for V2. Okay, so then to get it into the form that we want everything to be divided by 10. So we're just going to manipulate this form algebraically. So to get 10s on the bottom, we're going to have 2v1 over 10 minus 42 over 10. And then the minus 10j, the minus j comes up to the top, so we'll get a plus j v1 over 10. And then a plus 2v1 over 10 and a minus 2v2 over 10 equals 0. So then we're going to just combine all of the like terms. So we have 4v1 over 10, and then a plus jv1 over 10, and a minus 2v2 over 10, and then a minus 42 over 10. So matching this in this form, we would say that A is 4, B is 1, C is minus 2, and D is a minus 42. So if I did want an A plus B plus C plus D value, you would take 4 plus 1 minus 2 minus 42. And in this case, then it would be minus 41 plus 4 is 37. So you would get 37 would be your answer. So for V2, we're going to, or the node voltage at V2, we would do the same thing. So we're going to just manipulate the equation to put it into the form we want. So converting these to tens, actually, I'm going to take that back. I'm going to change the expression again. So you guys will have this right. We're going to just do these over 5, just to make it a little easier. And then we only have to combine the V2s together. So we already have V1 over 5, and then V2 actually, we need to get these all over to the other side. So I am going to rewrite the whole thing. So 0, a minus V1, and then a plus V2 over 5, plus V2 over 0.1j, plus V2 over 5, and then a plus 10.5 over 5. So combining all of the V2s, we have 1, 2, well, I gotta get the common denominator, so let me go backwards, minus V1 over 5, and then a common denominator is gonna mean that we have a 0.1 V2 over 0.5, and then we have a 5 V2 over 0.1, and then the j is gonna come up to the top, so that becomes a minus j on the top. And then again, 0.1 V2 over 5, or 0.5, sorry, this is 0.5. Let's see, 0.1, yeah, that's correct. And then plus 10.5 over 5. And so we then combine these as minus V1 over 5, and then 0.1 minus 5j plus 0.1 all over 0.5 plus 10.5 over 5. So in the form of this, that gives that A2 so that means that A2 is going to be minus 1, B2 is going to be 0.2, and C2 is a minus 5, and then D is a 10.5. So this would be the solution for this type of a question.